कुछ दिन से ही चल रहा है अभी चलेगा.
Hello, hello, hello everyone. Are you all able to hear? Hi Nishat. Hello Lobo. Is the voice and the video proper for everyone? Yes, okay. We'll just wait for a few minutes, 1 or 2. All students will be there and we'll start. So today we'll finish this chapter, and once we're done with this chapter, we'll go with the previous year's questions. Hi Sumit. We'll go with the previous year's questions, okay? Hi Basha. Okay, just 1 or 2 minutes, everybody will be logging in, okay? So everybody ready? And for the second PU students, how is your Hindi preparation going on? How is the second Hindi preparation going on? And for the CBSE students, your physics exam is on Friday. So how is the preparation? Basha, PYQs of this lesson are damn chill, Basha. Leave it to me. You will see, you'll be able to solve it. Very simple. Don't take the tension, okay? Till I'm there, don't worry. For all of you, okay, don't worry. All the PYQs, leave it to me. I'll show you how to do it, and after that, you'll be feeling it like done. So math and data, anybody is feeling not feeling any difficulty, no? Now physics also you won't be. Just don't go too deep into the topics as of now. For CET students, I'm telling you a very honest fact. We are right now not doing PhD. Hi Heath, we are not doing PhD on this chapter of physics. Okay, it's very deep, and a lot of is there to understand, to learn. Okay, but what I'm telling, that this point, this derivation is not important. This topic, this formula, this things are important. So do those things. Rest all will be done. Don't go too deep. 30 days will be very less. Just wandering into one chapter of electrostats, you can leave. You can, what do you say, go here is like, okay, math and that is like makhan now. Damn good, Basha, damn good. Okay, now, so every chapter of maths and physics will be like makhan. Okay, don't worry. So students, okay, only thing is, just don't go too deep. Listen to the words. Whatever the question will come, exactly similar, I'll tell you that these things will be coming. That's it. Okay, for the CT, I'm just telling it for the CT. Don't take the, yeah, bhaiya said for JE and all. Okay, JE different thing, CT is the different thing. Okay, just for CET kids, I'm telling. For CET, we have analyzed the paper and everything. CET and Comedk, they don't give anything here and there. Okay, not much. Concepts you should know, and how to apply them, that is the important thing. Okay, clear everyone? Okay. So I think so everybody has went through the previous things what I have taught. Correct? Clear everyone? You all remember the previous things, correct? So I'll be asking, just put it in the chat section, what would you remember? I'll be asking the formulas and all that. Okay, let's see. Tell me, can you give a practice sheet for math and that? Yeah, we'll be soon putting up the practice sheets also. Like, what do you say? Because right now a lot of live classes and everything going on. So just give a bit of time. We'll put up. Okay. Next. Okay. So let me just ask you a few questions. Okay. Now one question is very simple question. What to ask? Okay. Very simple. Let's see from Basha. Define electric flux. No cheating, okay? I want honest answers without seeing here and there, without seeing your old notes and anything. Just tell me, do you remember what is electric flux? This question is first for Basha and then others. Whoever remembers, do type it on the chat section. Come on, come on. Don't worry, Piyush. The Google Meet classes of chemistry also will be recorded and saved in the app. So don't worry. And this is there in the YouTube part also. Okay. Number of field line passing, Basha Road. What about others? Are you happy? Answer is correct, not correct. Nishat, Lobo, Sumit, Heath, through the unit area. See, that's why we say revision is the key, revision is the key, revision is the key. But students never listen. Very good, Karthik. Electric field lines passing through the surface normally. This word normally needed. This word normally needed. Okay, again Heath wrong, again Heath wrong, not complete. See where I told yesterday, I said field lines perpendicular to the surface. Field lines passing, okay, perpendicular to the surface. Still you messed up. Again wrong, Nishat, not proper. See, exact we need. Field lines which are perpendicular. A bit here and there won't. Perpendicular to the surface, okay. So very, very, very important, okay. Clear? Small details, okay, you need to know. Like see, if they'll give you, yesterday also I gave an example to all of you. 1 second just. So see, if they give you a surface like this and the field lines are passing like this, okay, the lines are this. So what will say how many field lines are there? What is the electric flux? You'll directly say 0, sir. For this surface, it should be perpendicular, not parallel to the surface. So here, if by definition of Basha, if I'll go what he said, field lines passing through the unit area. So this unit area, how many field lines? 3 passing. So answer will be 3. Wrong. So small details in CT is important. Okay. Small details is important. Clear, Basha? Okay. Yes, no. See, I just took this example to show that where students commit silly mistakes. Small mistakes that can cost 1 mark. Very, very, very important. Okay. Where is Lucky? Where is our Lucky the racer? Okay. Now, so everybody, revision is very, very, very important. Okay. And try to pay attention to that part. Now, Nishat, you tell me, what is the direction of electric dipole? Nishat, what is the direction of electric dipole? See, we'll keep the class interactive. Okay. Though you are in YouTube, doesn't matter. Wherever we are, we'll be keeping it interactive. See, we are not here to hurt anyone. We are not here to show anyone down. We're not here to show you're bad, good, nothing. We're here to make our rank good. Okay? So here, try to participate. Even if you're telling a wrong answer, who cares? Clear? Clear? It's not like I'll be going and complaining, yeah, to what you say, Karthik parents, this kid has said a wrong answer, nothing like that. So chill. So here I'm just there to improve your rank, okay, in the CET part. So do participate, tell the answers if you're there. So Nishat, I asked, okay, along negative charge. Along the negative charge. Along the negative, you can say better is for what? The best way? Direction is from negative to positive. Negative to positive. From negative to positive. Going from negative to positive. Yeah. Okay. So very simple. Negative going towards positive. Clear? Okay. Very good. Very good. Now, small things they'll ask, okay, because in the heat of the moment of the exam, because see, understand the situation. That's why I'm keep explaining again, same thing. You might be bored sometime. See, for CT and Comedk, every time your per question you just have 45 seconds, students. In that 45 seconds, no, if our brain thinks a bit half of the part, we can put a wrong answer. Clear? So always make it clear and again say it to yourself, okay? In JE and all, we have 4 minutes. So we can think on the question, reflect it. Here we don't get time. Okay? If that same CT question, if I give it for you for to write for like, let's say, per question 5 minutes, you would have done very easily. Sir, 5 minutes we can easily think, understand what they're trying to trick us and everything. But the moment I play the time game, you just have 30 seconds per question. So what your brain is? 30 seconds. Very less time. So done. There only students do mistake. So that we need to put up a habit. Okay? Clear? Chalo. Coming, Basha, coming. They say fast work is like a devil's work. Correct? So, tell me, Basha, if I am increasing the radius, okay, and making it double, if I'm increasing the radius and making it double, what will be the change ratio of electric field and the force? Find the ratio of electric field and the force. Let's see, you can say. Two charges are there. Understand the question. Very simple, very easy question. Two charges are there. One plus, one minus. Okay. And this distance is r. Suddenly what I have done in this is the first case. Suddenly in the second case, I have doubled the radius to r. Now I'm telling that what will be the change in what will be the new electric field and the new force, and what is the ratio of that. Correct. What is the ratio of that? A very simple question to all the brainiacs here. To all the brainy students, come on, think. A very simple question I've given. What I told, when the first positive charge, negative charge are distance separator. Correct. And then you have to, suddenly what you have done, you have made the radius double. Now what is the new electric field and what is the new force? You have to find the ratio. A very simple question. Find the ratio. Let's see how many people are able to do. 1:8. 1:8. Okay, Nishat, come on. Okay, electric field, new electric is E by 4. 1:7. You can't change answers like that, Nishat. Okay. 1:8, 1:7. You can't change like that fast. One answer. I always told no. But this one also one very good habit. Always first when you be confirmed, then put the answer. You have to be fast. That is good. But in being fast, you can't, what do you say, just keep putting answers. You have to, one answer you have to put and make sure that that is correct. What about others? Karthik I got. Karthik, I didn't get the exact answer. I need, what is the new force? What is basically, I need the ratio of new electric field new by force new. Let's see how many people can answer me. Let's see. Heath is telling force is 1 by 4. I never asked about the force. I want E by N. E by N, students. 1:8. Nishat still strong going with, not going with 1:7, Nishat. What about Lucky? Where are you, bro? And where is Jaswin? Come on, keep writing answers, you all. Okay. So everybody should write answers, okay? And it's nothing like only 1 or 2 people will be writing answers. Okay, let's see. Lucky E by F. E by F. Okay, okay. Came late, but not bad, Lucky. Good, good. Okay. So by radius 2r and by volume formula we get 1:8. The ratio is okay. Understand, understand. Okay. Now see, we don't have to go into the volume and other part, but see here, understand, very important. E is inversely proportional to 1 by r square. F is also inversely proportional to 1 by r square. So if I do E by F, both and both will be cut. Correct. So E by F won't change. If what do you say, the new E is becoming E by 4, new force will also become F by 4. So by 4 will be cut. So the new and the old will become the same thing. The first person to say that is Lucky. Not bad, not bad. Heath came late, but okay, not bad. Hi Sumit. Okay, so everybody understood. Nishat ma'am, did you get it? We don't have to go inside force because we didn't say it's a spherical charge, something charge is there. Okay, point charge is there, not on a sphere or something, nothing. What I said, so you need to remember what is the relation of electric field with R. So E is inversely proportional to 1 by R square. I made you all do this also, correct? E is inversely proportional to R square. And if you see, F is also inversely proportional to F is also inversely proportional to what? R square. Done. So we can, by that, we can directly, done. Clear everyone? Very good, Nishad, very good. So we should understand what they're asking. Otherwise, we would have wasted the whole time. Okay, they won't give us something like big or something. Okay, so very simple question. See, this is a, where is our Basha sir? F by 4. Running fast doesn't guarantee success, correct? Everybody remembers the story of what? A rabbit and a tortoise, correct? We should not just run fast. How will you do the PYQs, Basha? Huh? If you do like this, very simple question, concepts. Okay, physics, what is important? The concepts. Understand how is one thing related to other. Use that. Done. 1 second, students. Yeah, I won't let you go anywhere, Vasha. Be here only, okay? We have to, just like 3 idiots, we can't let hold of our students to go. All weak students, we have to take care of everyone, okay? We have to work hard, 30 days, make them good, then done. Okay, be the best result. Give the best result, okay? Now let's see, students. So everybody, you need to revise like this, okay? The revision should be, it should, see, all these questions are very simple. And you have already learned all this in 12th. Correct. Class 12th, you have already went through this. What is this? Or electric charge, fields depends on this. Force depends on this. But to recollect that in that small time, okay, is very important. Hi, Venkat. Okay. So everybody, you need to think like this. In exam, not very difficult questions. What happens is a lot of times, a lot of people will come and say, very difficult IIT. No, nothing questions of IIT comes here. See, never IIT question can be coming in CET. How? IIT one question, 25 questions are there, 3 hours is there. Per question you get 4 minutes. So they can mix concepts and give you. Here we are getting per question 45 to 50 seconds. Max 1 minute. How can they give mix up such complicated things? So simple is there, but we have taken in our hearts, it is tough. Nothing like that. All chill. Clear? Hi Shinde, okay? Chalo. So everybody got it till here. Revision is the key. Revision is the key. Okay, everybody we have to revise. Simple things. Revise Madi, you'll get it. Okay. So let's see now what else we can give to you all. Chalo. Principle of superposition. Okay. Now one very simple question. I've already explained. Hi Shinde, okay. I've already explained. Let me ask one simple question of the concept part. Okay. Now one more thing I'll do from after tomorrow's exam. Okay. Per day when you're coming with the YouTube section, whenever you're coming with the YouTube class, I'll tell you what to revise tomorrow. So just like normal coaching class used to revise and come to the teacher, tomorrow what do you say? Every of the YouTube class you will revise that part. You will come. I'll ask you simple, easy questions where you can check. Oh, this way I need to use it. Done. Clear, everyone? Now a very simple question. See, this dabba is there. Two charges were there. One positive, one negative. Okay, kept in. This is water. H2O. And another kept in what is this, student? I think so everybody knows. Correct. CH3OH. Can I get the name on the, what do you say, screen, students? What is CH3OH? One charge here. Same. And here also same. Okay. CO2. Now this is H2O. That is, we all know water, a lifesaver. And this is CH3OH. Can I get the name from the students, please? What is CH3OH? Two electrons, one is dipped inside the water and the other is dipped inside CH3OH. Can I get the name of CH3OH? What is it called generally? Come on. It is not called, sir. Methyl alcohol. Very good. So here we have dipped in one in alcohol and here the other two charges in what? Or methanol, okay. In water. Now kids, you tell me, here epsilon is given, epsilon of water is given 2 times of epsilon naught. And here epsilon of alcohol or methanol, this is the rough data, my main own made up data, is 3 times of epsilon naught. Where is the force maximum or minimum? Force H2O means the force between charge in water and force in methanol. So which one is stronger? Who can tell me? Think, take your time. I'm putting on the timer. Take your time. No need to be in a hurry. Okay, and then give me the answer. 2 minutes I'm giving you all. Okay, and then give me the answer. Clear? Every day, everybody, listen to the question. Okay, don't be in a hurry, Lucky. Okay, so what we have done, we have taken a dabba. In that dabba, what we have done, okay, water is there, we filled with water, and then we dipped two charges, plus and minus. So electrostatic force will be there. Very good. Now electrostatic force is there, but we have given one condition, that epsilon of water is 2 times of vacuum. And here in methanol case, epsilon of methanol is 3 times of vacuum. So which force? The force here, the electrostatic force here between water molecule, between here, two charges which is kept inside water and two charges which is kept inside methanol. Which one will be stronger? Which one will be stronger? It's a very good question, but very simple question. Rest all, distance, everything, charge, volume, everything is same. Rest all, that plus charge, minus charge, the distance between them, everything is same. Okay, let's see how many correct answers I can get. I'll give you time, no need. And see, the answers is there on top only. If you understand very properly, I've given you all the formulas here. Okay, F medium, everything I've given here. So let's see who can tell me the correct answer. Shinde, we can't give so many options. One option you gave one, another two, another alcohol, another okay, not like one answer. Everybody try to give just one answer. Come on, come on, come on. We'll solve all your doubts, Shinde, don't worry. Let everybody have the time. Think on it. See, I've given you, students, all the concepts which you need to solve. Just like earlier question, understand what is, first ask yourself, what I need? The answer will come, force. Ask yourself what you need. Answer will come, I need force. Now ask yourself, force depends on what things. So you'll say, sir, force depends on this charge, this charge. But since you have said both of them same, so I can neglect. No, sir, force depends on radius also. But since, sir, both of them is same, I can neglect. Now 4 pi is constant, sir. So force is inversely proportional to 1 by epsilon. Now think, done. Come on, everybody. Lucky first said methanol, then said water. This option, this way I can't allow, Lucky. Correct. One answer, one at a time. If you say water, stick with water. You can't just go to a restaurant, ask water and then alcohol. Correct. One. Just kidding. Okay, don't worry. WhatsApp group will do later after the class. Don't worry, Shinde. So क्या भाषा सर आपके लिए वाटर को लॉक कर दें? लेट्स सी. चलो बाकी बच्चों के लिए क्या करना है? Vimal, max in water, minimum in alcohol. Kartike, water. Water, hydrogen with water. Okay. चलो, तो वाटर में क्या हो रहा है? चलो थोड़ी देर के लिए मान लेते हैं ये जो एप्सिलॉन नॉट है ना, ये वैक्यूम का, इसको मान लेते हैं ये 1 होता है, मान लो ये मान लेते हैं, क्योंकि ये सेम वैल्यू, कुछ भी मान सकते हैं। तो द मोमेंट हमने इसे मान लिया कि ये 1 है, तो एप्सिलॉन ऑफ वाटर क्या हो गया? 2 हो गया। फोर्स क्या? इनवर्सली प्रोपोर्शनल टू 1/2 हो गया। अब इस वाले, ये वाटर के केस में है। अब मिथेनॉल के केस में क्या हुआ बच्चों? अल्कोहल के केस में, ठीक है, 1 चूंकि यहाँ पे 3 था तो 3 हो गया। तो इसका डिनोमिनेटर तो बड़ा है, तो फोर्स क्या हो जाएगा? घट जाएगा। इसका डिनोमिनेटर छोटा है, फोर्स क्या होगा? बढ़ जाएगा। सो दिस फोर्स विल बी मोर। दैट्स इट, डन। सो आंसर व्हाट विल बी? वाटर. फॉर दोज हु हैव सेड वाटर, गुड. Okay, hydrogen with water is also good. And what about others? Good. Basha, max with water. Who said alcohol? Water, water. Chalo. Clear everyone? Very simple question it is. But fast, when we started doing fast, a lot of people would have done mistake. Clear? Nothing is there in the questions, okay? Physics is also damn chill. Clear everyone? Yes, no, yes, no. Put in the chat section if you have any doubt, any doubt. Concepts are getting clear, yes, no. Give me, sir, give me number. We have already given so many times in there. It's there. 8050491740. Clear? Done. Good. Good, Nishat. Chalo, ab next concept, we'll go for the next concepts, okay? So revision is done. I got to know like how much you have prepared. Now this is the way you need to revise for the other classes. Same way for the maths, same way for the physics, and same way for the chemistry. Whatever ma'am will be teaching for chemistry also will be informing beforehand so that you can join the class, understand the chemistry, and do awesome. Okay. Chalo, next when we see, let's see the next part. So that day we were doing electric field due to dipole. Correct. Now, in this student, what is important to remember? First, this part, mark it down. This part very, very, very important. Okay. A lot of times questions have been made in from that part. Okay. A lot of times questions have been made from this part. What is the direction between electric field and dipole moment in case of axial point? Okay, clear? Now, then this formula is important, and for a short dipole this formula is important. That's it. Okay, nothing much comes. Okay, if you know these 3 things, that is more than enough. Everybody do mark it down, do write it down. Take a pen and a paper, do write it down. What do you want to know, Shinde, about Kcet? Clear? Now, so that much we need, nothing more than that we need here, okay? Now coming to equatorial point. Everybody coming to equatorial point, what we need here? See, in equatorial point, first what is there? What is the equatorial point? First, we need to have an idea what is an equatorial point, okay? See, we told what is the axial point. This is one electron, one charge. This is another charge. This is the line joining the centers of the charge. So this line is known as the axis line. So any point lying on this line is known as point lying on the axis or axial point. Okay. Now, if any point is lying in the perpendicular bisector of the axis, that is known as equatorial. This is the axial line, perpendicular bisector of that. If any point, anywhere you're lying, that is known as the equatorial point. Clear everybody? Clear everyone? So what is equatorial line? Line perpendicular to the axial and passing through the center of dipole. So same thing, perpendicular bisector it is going. Clear everyone? Line passing parallel to the axial, perpendicular to the axial and passing through the center of dipole and passing through the center of dipole. Clear? Now, so here this charge will, whenever we do, we always keep a positive unit charge. So this positive will be attracted towards itself. Okay, this positive, what will do? It will repel, positive, positive. So the net electric field, if I use the resultant of the vector, will be in between. Clear? Done. So here what we are seeing, dipole moment direction is like this and electric field direction is 180 degree opposite. My dipole is like this and electric field in this case is like this. So this point, mark it down, important. This point, mark it down, important. Next, this formula, important. This formula, important. Clear? Hi Tulsi ma'am. This formula, very, very, very important. Okay. Next, for the short dipole, again very important. So again in these things, three things are important. What? Number one, what is the angle or direction between dipole and electric field? 180 degree. 180 degree. Second thing what we need to remember. This formula. Third, what you need to remember, for a short dipole means the x value is much greater than 12. Okay, or the r value is much greater than 12. Okay, clear everybody? Clear this point? Yes and no in the chat section. If you don't have any doubt, put ND. If you have a doubt, put a D. Clear everybody? Clear everyone? What's your doubt, Shinde? No doubt. Good. Let's go to the next page. Now the relation between whom and whom? Axial and equatorial. Very, very, very important. Relation between axial and equatorial, very important, mark it. Okay. First, axial and equatorial, if you do the mod wise, electric field at axial point is 2 times the electric field at equatorial. So which one is bigger? The axial. Clear everyone? First, very, 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 very important this point. The electric field at the axial point is twice the electric field at the equatorial. What about the direction? Same thing, 180 degree, because axial and dipole moment direction is same. This is axial, this is dipole moment. Okay, and equatorial is opposite, equatorial. So these two things from here, very important till here. Very, very, very important. Okay, the way I'm doing, same way you need to keep it in mind. Then questions will be going like this. Clear everybody? Nothing here, nothing extra needed, nothing. Clear everyone? Chalo. Next. E axial is equal to Karthike 180 degree. What about 180 degree, Karthike? See, axial and this one same 0 degree, and for this one 180 degree. Equatorial, correct? Done. Anything else doubt you have? Basha wrote, sir, in PYQ it was E axial equal to 2 times of E equatorial. -2, yes. -2 why da? Because direction is opposite da. If I'm talking in the vector sense, it is opposite. Here it is mod part. Okay. Because see, that's why it mentioned the direction also. One direction is like this, one direction is like this. That's why a minus is there, Basha. Clear, Basha? This is like best way is put up a mod now. Okay. Yeah, because in PYQ they're talking about the vector. Okay. Clear, huh? Okay. Now you said, sir, you got for a axial line, you got for a equatorial. What about any point? Dipole is there. Correct. This is the dipole, sir. It is neither lying on the axial point nor lying on the equatorial. Somewhere here the point is lying. Okay, making an angle theta with the dipole. For that, this is the formula. For that, this is the formula. Though they rarely ask, this is not for what? CET, but still I've given in case if you're like, what do you say, if your life is not going that good and sometimes some questions out of the blue out of 10 years they come up, then they can ask this. Else in CET they never ask. But still to be on the safer side, I've given you all. Clear everyone? So if you put the value, you'll get the exact answer for axial, what we have derived, and for equatorial. Clear? Do write it till here. And everybody make a practice of writing along with me. Make a practice of making notes along with me. Okay? If you want, I can go slow, doesn't matter. But make a practice of writing along with me. Okay? Clear everyone? Be fast. Clear, clear, clear. Good. Will I go to the next page, students? Chalo, let's see. Next part, what we have. Now this question, mark it very, very, very important. Once or twice it will come. One question out of three always has a chance to come. Always it has a chance to come. Okay. Dipole kept in a uniform electric field. Dipole put in a uniform external field. So now in that case, two kinds of question comes. One uniform, one non-uniform. Clear? So first they'll put it up in a non-uniform or and in a uniform. So here, first case, we are putting in a uniform electric field. So what we have done is, we have taken a uniform electric field. Clear? How do we show uniform electric field? Straight lines. The moment it's straight line, not like curvy or something, it's uniform. Okay? Means if you go from left to right, all the values of the electric field remain same. Uniform means if I travel from left to right, the value of the electric field remains same, student. Clear? Now, so I've taken uniform electric field. Clear? And I've then placed a dipole. I have placed a dipole. Now what will happen? At this point, F is equal to what? Charge into electric field. F is equal to what? QE, charge into electric field. So force will be acting like this. And for this side it will be, for negative charge, it will be opposite, like acting opposite. Correct? So whenever two forces are there, one in one direction, the other in another direction, what will happen? What will happen? See here, everybody. So one point the force is going like this, another point it is going like this. Clear? So what it will do? It will try to rotate. Correct? One force is like this, another force is like this. So what it will do? It will make a rotatory motion. So that's why a rotating force or couple or torque acts on it. Clear everyone till here? Very simple, very easy. Everybody got it? Clear? Now what is the value of torque, or how do we find the magnitude or the formula of torque? That we already know, and that is what? Because here in torque both the forces are same, either force, okay, into perpendicular distance between them, not this distance. Okay, between this force and this force, we're not talking about this distance, the perpendicular distance between them. Clear? Everybody, the perpendicular distance between them. Don't do any mistake in that, okay? The perpendicular distance between them. Clear everyone? Chalo. The perpendicular distance between them. Now, either force, just now I told force is what? QE. And the perpendicular distance between will be what? This is 2L. Okay. So, if I want to write this part, this is theta. So, what will be? Take this triangle, find sine theta. Sine theta is what, students? Perpendicular by base. So perpendicular distance and perpendicular by hypotenuse. So perpendicular by 12. So perpendicular will be equal to what? 12 sine theta. Clear everybody? So perpendicular will be what? 12 sine theta. So we got Q E into 12 sine theta. Now Q into 12 we already know that is what? Dipole moment, and E sine theta. So we got torque is equal to P cross E. Now we already remember A vector cross B vector is what? Mod of A mod of B into sine theta. Clear? Got it everybody? Very simple. Okay. Now we got the torque part. Now next important part. Okay. So first till this part let's see. Now we got torque is equal to PE sine theta. Now if it is 0 then what will happen? Torque will be also 0. Sine 0 is what? 0. So it will be stable. Stable means you have kept a, what do you say, like this equilibrium. If you push it that side, it will again come back. If you push it that side, it will again come back. So very stable equilibrium. If theta is 90, torque is maximum. Clear? If theta is 180, torque is 0, but it is unstable equilibrium. Clear? So this point is very, very important. Everybody, this point is very, very, very important. Again, this point is important, and along with that, if you have kept a dipole in non-uniform electric field, then in that case what will happen? Net force here will be what? F1. Because the electric field will change here, and here electric field will be what? Due to electric field, force will be different, F2. So for both the force, net force, some value will remain. Net force will be there, and net torque may or may not be 0. We won't be able to say. Net torque may or may not be 0. We won't be able to say right now. Clear everybody? Go through this part. Very, very, very important. Okay? 1 second, students. Everybody got this part? Okay. Dipole in non-uniform electric field, what happens, Karthik? See, this is non-uniform. Okay. So we kept our dipole here. So the force acting here will be one value for F1 and the force acting here will be another value F2 because force is equal to what? Q into E. So here electric field is not uniform. So here whatever the electric field will be different. Okay, let's say E2 and here the electric field will be what? E1. So that's why the value of force here and here changes. So if I want to find net force, always one or the other value will remain. Clear? And torque we won't be able to commit. That whether it will be zero, non-zero, we can't say anything. Clear everybody? Yes, no, put it in the chat section. Clear everyone? Chalo. So everybody clear? What about in uniform, sir? Okay. In uniform, what happens? Here also force is same, here also force is same. So the force is same. If I want to find net force, F net, it will always come to be 0. Okay. So only a rotatory force is there, no rectilinear force to move it, and that is torque, that's only there. Okay. And that value we have found it out. Clear? What about others? Did you get it? Not get it? Yes, no, please in the comment section write down fast. Nishat, Shinde, I need others. Lucky. Tulsi ma'am, if you are there. Heat. Net force in uniform electric field is 0. Yes, correct. See, force is a vector quantity. No, we can displace this force here and this force here. We can bring it here. So this force here. So F here, F here. What will be F net? 0, no ma'am. That's it. Clear? Clear everyone? Net force is 0. So if you are placing it in a uniform electric field, net force is 0. That you need to keep in mind. Torque will be there. And what is the value of the torque? Pe sine theta. Pe sine theta. Now where conditions it is stable? At 0 it is stable. 90 it is max. And again at theta equal to 180 degrees unstable. So very, very, very important. Okay. These points you keep that in mind. Very important. Clear everyone? Okay, Vimal, good. Any doubt, without any hesitation, do ask, okay? Done, done, done. Next, we talked about force and we haven't talked about work. How can that be possible? Correct. So whenever we are applying some force, we want some work to be done. Correct. When you're trying to move the table, we don't push the table just to push it. Correct. We want the movement in the table. Correct. So here we need to know what is the work done. Now work done is equal to what? In normal part, we remember work done equal to force into displacement. Here, since we are rotating, so displacement in terms of what? Angle change. Displacement is coming in terms of what? Angle change. So torque, the rotating force, into d theta. How much you have rotated? How much, by what angle you have rotated? So work done is equal to what? Just like force into displacement, here it is torque into d theta. Clear everybody? So Pe sine theta d theta, that is work done. Clear everyone? Now this formula, I haven't shown the derivation. We can rotate and we can show all that. But I've directly given work done is equal to Pe cos theta 1 minus cos theta 2, where a particle is rotated from angle theta 1 to angle theta 2. Yes, angular displacement. Clear? So work done is equal to what? Pe cos theta 1 minus cos theta 2. This is nothing but the energy which is stored in the form of work done, which is stored in the form of potential energy. Clear? Clear or doubt this part, students? So we can take a particle, okay. First it was having from theta 1, now you rotated it to theta 2. Now work done in both the case is equal to, you have to subtract and you'll get the answer. No issues like that. Clear? Got it? Now, very important, see it like this. Always if this is my area, the area vector is always outward perpendicular. Outward normal, always remember. The normal or the perpendicular which is coming out of this, coming out of any area, if I keep it like this, it will be like this. If I'm keeping it like this, area vector is what? Always outward normal. Outside which normal is coming, that is always area vector. If I take this phone part, area vector will be what? Outward normal. Outward normal, okay? Clear everybody? Clear everybody? What is the area vector? Always and always outward normal. Clear? So if this is my area like this side, so outward normal. If it is kept like the table side, so outward normal. Clear? Clear everyone? Fast. Do type it in the chat section. Yes, no, yes, no. Because of very less is left. Just Gauss law and few applications. That's it. Done. So the whole topic is done. Then we'll take a 5-10 minutes break and we'll come and pounce on the what? Correct. Perpendicular to the plane also you can say. Clear? We can say outward normal, perpendicular to the plane also. We can say that. No issues on that. Okay. Then we'll go for PYQ today. Everybody's having energy, no? Now, okay, good. What about others? Yes, no, yes, no, yes, no. Everybody got till here? Next, we are going with the concept of flux. Flux denoted by phi is equal to what? E dot A. Electric field dot area vector. E dot A. That is equal to EA cos theta. EA cos theta. Clear? What is the unit of flux? Newton meter square per coulomb. Newton meter square per coulomb. Done. Clear? Okay, good. So this page whole clear? Okay, no doubt anybody? And everybody has written the formulas, because in PYQ I won't be able to again come back here and show the formulas. So I want you all this to be written and it should be like properly printed in your hearts. So whenever I say, oh yes sir, this is the formula, we'll apply, we'll get the answer. That's it, done. Nothing more than that, okay? Clear everyone? We'll come to the other formula also. Don't worry. Next, Gauss law. Everybody knows what is Gauss law, correct? Yes or no? Yes or no? How many doesn't remember Gauss law? Our favorite sir. And what did he say? A lot of questions keeps coming from this part also. Very simple, very easy, and nothing difficult here. Clear? Now what is there in the Gauss law part? What is there in this part is, let's understand Gauss law. The total electric flux through a closed surface is equal to, let's say this is a closed surface, okay? And I want to know what is the total flux. So how will I find it out? First, for that I need to find what is the charge this surface is containing. You will say, sir, Q charge it is enclosing. So Q charge divided by epsilon. Done. Clear everyone? Clear everyone? Now let's say they have given us a formula A charge is 1 plus q, 2q and minus 2q. What will be the flux? Tell me the answers fast. Tell me the flux, students. What will be the answer? This is a Gaussian surface. So what will be the answer? Karthikeya sir wrote 0. I don't know whether it is correct or wrong, but he wrote 0. What about others? You want to write something different? Anda. Everybody is writing anda. Wow. That's not bad. Anda 0, anda, not bad, not bad. What about others? Is it anda or 0? Just anything other than that? Where is heat? Vimal, where are your answers? Charge by permittivity. I have already given the charge for this surface. Find out the charge and tell me what will be the answer, Nishat. What about others? Keshav. What about others? Lucky wrote. Vimal didn't write. Shinde, I think so, it's absent. And I'm not able to see answers of heat. So both are not there. Okay. But okay. Okay, heat will be, charge will be 0. Good. You're signing off with different phones, huh? Very good. See a damn simple question. For this surface dA, what is the charge content? One positive, same negative. So total charge, net charge is 0, no. So 0 by epsilon naught will be what? 0. Done. Clear. So Gauss law always said is phi is equal to nothing but charge enclosed by epsilon naught. Done. Clear? Next. Applications of Gauss law. Now here, derivation part we don't need. They never ask anything inside. What they ask? Formulas. Okay, the values they will ask you to find. Now if I have an infinitely long, straight, uniform charged wire, what qualities it should have? It should be infinite, it should be long and straight, it should have uniform charge. If all these are there, what is the electric field? Lambda by 2 pi epsilon naught r. So if I take lambda 2 pi epsilon all constant, so inversely proportional to what? R. Clear? So very important. Clear? Okay. Electric field direction, check it. Outside, outside, very important. Lambda is what? Lambda is what? What is lambda, students? Charge by length. What is lambda called? What is it called? Come on, somebody should answer at least. I know my chat sections load a bit slow, but still. Come on, come on, come on. What is it? 3 types of charge density we study. What? Line, volume, surface. Correct. If we talk anything charged by length, anything charged by area, anything charged by volume. So what is this, students? Come on, come on. Linear charge density. Okay, done. Very late, but okay. Not surface. Surface means by area. It's linear. We are doing by length. Okay. Good. So this one is clear, everybody? Yes, no in the chat section. Clear everyone? We'll go for the next. Okay, good. Let's see the next one then. Electric field due to thin infinite plane sheet. Now what are things we need to know? It should be thin, it should be infinite, but plane sheet. So when we have thin infinite plane sheet, then what will happen? Electric field is sigma by 2 epsilon naught. Now what is sigma? Sigma is charge by area. This is surface charge density. Surface charge density, SCD. Okay, clear? So diagrams very important. Clear? Got it? A bit. Today a lot of things were there, but it's okay. But we'll do, don't worry. After this, okay, we'll take 10 minutes max break and then we'll come back for Hindi. Correct? Just kidding, PYQs. So we are almost about to finish this chapter also today. Clear everybody? Yes, no, do tell me yes, no. We'll go for the next page and everybody is writing along with me. Yes, no. Clear? Okay. No doubt. Let's see the last part of this. Spherical shell. Very, very important part. Okay, and everybody should write all these formulas and everything should write. Write down fast. Write down everybody fast. Write down. Very, very, very important. Spherical shell. So this is the shell. Okay. Now if I'm finding for a point which is outside the shell, what is the formula? This one, electric field. If I'm finding at the surface, what is the formula? This one. Inside nothing is there, no charge. For a spherical shell, for a conducting part, all charge resides outside or on the surface. So electric field inside is laddu. Clear? For non-conducting, charges will stay inside. So when outside, this is the formula. At the surface, same formula. Inside, we'll see how much charge it will contain. So that's why this formula. Clear? This part is important, huh? Clear, clear, fast, fast. Where are the other kids? Written everybody, Karthik, Vimal, Lucky, Basha, Nishat, Heath. It's okay, Basha, it's okay, chill. See, if I'm not able to work hard, then how will I tell you all to work hard? Correct? So first, when you're telling something others to do, you have to do also. Yeah, health is there, it's okay, we'll maintain. But a bit we have to work hard also. Because almost chapter this is done. Okay. So once this is done, the diagrams are very, very important. You can see one question from this part also. So this diagram is again very important. I want everyone to draw. See, inside the electric field of a conductor, no electric field. Inside the conducting, what do you say, shell, no electric field. At the surface, directly hiked up, and then it goes down. The more you go away from it, the more it goes down. Here, inside, if you come at the center, 0. Moment you increase some charge, again increase some charge. At the surface, max. Again, if you go beyond, it goes 0. Less, less, less. Correct? Done. So we'll take a 15-minute break and then we'll again be back. Will you be able to do the PYQs? What do you say, students? Because plan is to start the PYQ today. PYQs are good. We should do it. At least start it today. See how much you are able to do. Okay. So that tomorrow we'll be able to finish it. Tomorrow this chapter will be done. And we'll start with the capacitance. So this chapter now you're feeling it easy. Anything difficult? Anything tough? So very simple chapter, only few things you need to do. Okay, don't concentrate too much in depth here book, that book. When we'll be solving the PYQ, whatever I taught here, that should be more than enough to crack that. That's it. Clear? And good. So for all, do inform all your friends, okay, about the channel and about the course, okay. Good. So this is all done, students, okay. So we'll go and we'll take a, what is a 15-minute break. Whoever wants to eat, eat something. Drink something. Does not drink anything containing OH. Okay. Anything containing H2O is good. Clear? Everybody got it? Try not to take anything containing OH. Anything with H2O is good. Okay. Okay, we'll be right back. Chalo. Hello, hello, hello. The center of the sphere is from the origin. Okay, okay. डाउट क्या है बच्चों? बताओ बताओ बताओ. Yeah, Karthik, tell me. Is the last all clear, everybody, till here? Electric field at the point of position vector. What do you mean by that, ma'am? इस पॉइंट पे आप जानना चाह रहे हो? इस पॉइंट पे इलेक्ट्रिक फील्ड क्या होगा? What will be the electric field at this point? What is your question inside the sphere? See, if I come to the inside the spherical shell, I know for a conducting spherical shell, all the charge resides on the surface. All the charge resides on the surface. So what will happen? Inside no charge, so no electric field. So that's why inside is 0. Clear? Clear, huh? For a conducting spherical shell, just write down here conducting part, it will be more easier. All the charge resides on the surface. All the charge, whatever the charge will know, if you give it to a conductor, what happens? All the charge will go in the center only. Nothing goes inside. Hi Fahd. So that's why inside it is 0. Clear? Where are other kids? Basha, Vimal, join fast. Hi Fahd, preparing for CET? Chalo. Let's see everybody. So till here everybody got it? Any doubt? Okay. Good. Sorry Fahd, I didn't remember only, so sorry for that. But good. So what you have taken? Which stream? And how is everything going? All going good? Where are others? Fast, join. We have a lot to cover up in the PYQs. Come on, fast. We'll start with the question answers, okay? I'll be back in a minute. Okay. CS in Dhyanand Saga. Good. Enjoying my hectic first year in Bangalore, and it was good experience. Good, good. Bangalore life is a bit hectic, yeah. Okay. But the weather is good. At least now it is good. Earlier it was not that good. In between it went bad, but yeah. Now pretty good weather. It's way chilled than any other place. Okay. So pretty good weather. Let's see. Come on, everybody, join fast. Had your food, dinner, everything, join fast. Yeah, sure, Fahad. Okay. Regarding the coding, if you want, you can meet me also. I'm what is it? Not far. Like in BTM Bangalore, I'll be there. Okay. So if you want, you can come at the center. And regarding coding, you can have a discussion. Okay. Whenever you are free, you can come down also. So no issues. Okay. Yeah, you can contact via the call also. No issues in that. And if you want to meet, you can come also. No issues. So let's see. Let's start with the questions, everybody. The first question on the screen. Chalo, everybody see the first question. Sure, Fahad will definitely meet. Okay. So answer is one kid said B. Kartikeya, you can't change your answer later, huh? Let's see. What about others? We got one answer as B. What about others? Come on. We need answers from everyone. Basha came B. What about others? What about others? Come on, come on. I need answers from all of you. See, this question we have already done. No, charge of a body is this one. So how many electrons are present? So what are you going to do? Q is equal to any. Charge is given. They told you to find the number of electrons, and we know what is the charge of one electron. Done. So find out fast, fast. Option B, very good. What about others? Good.
अरे आपका दिल इतना बड़ा है।
Chalo. Voice not audible. No, I just muted it. We were just checking for the times part. Okay. Now, so very simple. This everybody got. The answer is B. Okay. Clear? For Karthikeya, don't worry. I'll again explain that part. No issues on that. Okay. Now, let's see the next part. Very simple. Very easy. The next question. Try everybody. Very, very, very simple question. Okay. I'll just reset the timer. 2 minutes I'm giving you. Later I'll start giving 1 minute only. Voice not getting, Nishat? Hello? Are you not getting the voice? Getting or not getting the voice, ma'am? What about others? Are you able to hear? Okay, okay, good. 11 और होगा शुंदा. Let's see. Chalo everybody, fast. Come on, everybody, come on. Let's see. Audible. Good. So as of now, we got just one answer, that is from Basha 2. Tomorrow at what time class? 10, sharp 10. Morning 10. Tomorrow maths, we are coming up with a new chapter, sets, relations, functions. 3, very important. CT Comedk, very important. Your base for the calculus. So don't miss it. Lucky came with a different answer, C. Let's see what about others. Will they go with Lucky or will they go with Basha? Come on, let's see. Sir, my answer also C only, sir. I told you my final answer. Basha said C. When? Basha answered 2. Answered 2. Okay. So C. Okay, answered 2. Okay. Got it. 2 is the value which you got after solving and the option is C. Got it, bro. Karthik C. Nishat ma'am, where are you? Yes or no? Very simple question. So Basha, how did you like the question? Crispy clear or ratio I told? Yeah, I got it. Or is it like Lay's Masala India flavor? What do you say? How is the question? Easy, tough? What do you say? What about others? I'm not getting answer. Where Keshav is not there, Vimal is not there. I think so they have exams. Hindi exam. Okay, will I show students? Clear? Let's see. So students, we all know, what we all know? That two equal charges are there and opposite charges of mass m1 and m2 are accelerated through a uniform potential. So what you have done, you have taken two charge and you have accelerated it. One is of mass m1 and another is of mass m2. But they're accelerated through same electric field E. Okay. So we know force is equal to what? Charge into electric field. Now the magnitude of charge and the magnitude of electric field is same. So if I find out the force F1 magnitude wise, that will be equal to what? QE. Correct. And that is also equal to what? Since they are accelerated, M1A1. Correct. Mass into acceleration. Same thing, F2 will be what? Mod QE. Okay, that is equal to M2A2. Clear? Till here everybody got? So A1 by A2. So what I can write? M1A1 is equal to M2A2. Very simple. So A1 by A2 is equal to what? M2 by M1. Clear? And M1 by M2 is given as half. So M2 by M1 is what? 2. So put a value 2. Done. Very, very, very simple answer. Clear everyone? Clear everyone? Chalo. Got it everybody? Yes, no, no doubts. Come on students, you have the energy or it is gone? Yes, no, energy is there or is it gone? No doubt, okay. Let's see the next question, a very, very, very simple question. A very simple, a very easy question. Let's put on the timer, students. Let's see who can answer this question. What will be the answer? What will be the answer? A. What about others? What do you say? Is it A? Karthikeya said A. What about others? Karthikeya first said A, then said not sure. Okay. No issues. Lucky said okay. Brother, he said A. Karthikeya said A, sir. I'll also said A. What about others? Nishat vector. Okay. D. What about others? See, let me tell you one very simple thing. What is that very simple thing is? Our teachers used to say this, okay, when we were there in Kota. One of my favorite teachers used to tell this story. Okay, what he used to say, that whenever in J and all a question comes, a bird is flying and, okay, and the coordinates of the, what do you say, height is changing as double times of the coordinates of the distance. What students used to imagine is the moment this, what do you say, they see the question that birds are flying, They'll start imagining, closing their eyes, the birds are flying, they're going with that speed. Nothing like that. What you have to do is don't put emotions here. Check with the actual formula. Now we all remember, students, what is Gauss law? E dot ds, electric field E dot ds. Gauss law says what? E dot ds is equal to what? Charge enclosed by epsilon naught. Now if you remember, this is vector. This is also vector. Dot product of two vectors gives me what, student? Dot product of two vectors gives me what? A scalar. And this side also what? Charge is scalar, epsilon naught is scalar. So scalar or vector? Scalar or vector? Still D we are getting. Scalar or vector? Basha, scalar or vector? See, this is area vector, again a vector. This is the electric field, again a vector. Two vector, if you do the dot product, A dot V vector, A vector dot B vector, do we get a scalar or we get a vector? Come on, come on, come on everybody. Do we get a scalar or a vector? Clear, not clear, clear, not clear. Is it clear for everybody or not clear? Yes and no in the chat section. Let's see, the chat is loading very slow. So do put everybody, whoever is there in the chat. Is the answer yes? Is the answer no? What is it? D only. Vector quantity. Sure. So the nature of Gaussian surface involved in Gauss law is what? Is it A? Is it D? Is it A? Is it D? Come on, is it A? Is it D? How many people are still telling it is A? And how many going with D? Why think so, Nishad? Now whatever the answer you say, at least say with confidence. No. A or D? A or D? What do you say? How many supporting A? Do put up. And how many supporting D? D. So the answer is D. Because the whole Gauss law E dot ds is a scalar, but the Gaussian surface is a vector quantity. Clear? Okay. Lucky got it. Kartike, Lucky got it, both of you. This Gaussian surface, it's a vector quantity, no. And what is it? It's a vector outward normal, always coming out vector. Clear? Got it, everybody? Yes, no in the chat section. Yes, no. So will we continue? I am seeing that the students are getting a bit tired. Or will we keep it till here? Tell me fast. Will we continue or will we keep it till here? Will we continue? Will we keeping till here? Keep till here, okay. What about others? Continue, finish off. Lot of questions are there, Basha. Nishat ma'am, good. Continue. Not bad. I'm seeing energy in the students. Okay, okay. Don't worry. Tomorrow we'll start with 2014. A bit questions are there. Then 2015 is there. We'll go with 16. Don't worry. No need to be in a hurry. 2017 will go. 2018 will go. I want to go a bit strong in this chapter. Very important. 19, 20, and 21. So tomorrow we'll be covering up everything. Okay. Just what I want from you all is to revise all the concepts which I have given. To revise the concepts which I have given. Clear, everybody? Clear? Hello, Raja. Do right answers also, Raja. What happened, Nishat ma'am? What, you don't think we will be able to complete tomorrow? Raja is floating with energy. Continue. Okay, what about others? Chalo, let's see. One more question. Lucky, keep it clear. A bit tired, Lucky. One last question will end it, okay? Chalo, one last question. This is potential question, okay, but still. This one will do it. What do you say? This is potential question. This one you do it. Let's see. We can do this also. This one everybody try. Let's see. Don't try that one. Try this one. That was easy also. I'm giving 2 minutes for everybody. Try. Let's see who's able to solve. Come on, come on, come on. Use your brains to the max and get the answer as soon as possible. Come on, come on, come on. Anybody got the answer? Oh, Raja got the answer. Let's see. What about others? Oh, Basha also got the answer. Very good, very good. A very simple question. Let's see what about others. A very simple question. What about others? Others, very simple. Just use the formula. Nice, Nishat. What about others? Let's see what about others. Correct. Lucky Karthik. Come on. One simple question da. Sir, when is integrals? Integrals will come. See, first we are going with sets. Don't hurry. If you go to integrals directly, it will be difficult. R and F. Okay. Then limit, derivative, C and D. After that, AOD. Then we go into our best buddy, integrals. Clear? So everybody see here. See, by seeing the option, we can say 3 will be there. Everything has 3. So I just need to check the power. Correct? So what I'll do, how will I solve it is, what I have to find? Electric field. What is the electric field formula? KQ by R square. KQ by R square. Correct. Here in this case, a sphere is there and a point is outside here. So D distance, and the radius here is what? 2 centimeter. Correct. And this D distance is what? 3 centimeter. So KQ by D square. So K is what? 9 into 10 power 9. Okay. Q is what? Charge? 3 nanocoulomb. 3 into 10 power minus 9. And again, this is in centimeter. Correct. So 3 into 10 power minus 4. Convert it in meter. So this power gone. This 3 gone. So this one will go up. So 10 power 4. Correct. Clear? Oh, I cut 2 3s. Oh, this will be 9, sorry. So this 9 and this 9 will go, this 3 will remain. So 3 into 10 power 4 done. Clear? LPP very rare question comes, Nishat, okay? For CET or for Comedk, max 1 question comes. So LPP will be going later. Clear? So first target is the scoring topics. Within that 20 days, all the scoring topics so that you can score more than 40, 45, okay, 48, 49 like that should be done. Rest 10 days will be like 10 marks. That's it. Clear everyone? Got it? Chalo. So we'll keep it till here, students. Okay, work hard, be honest, be dedicated. See you in the next session. Okay. Bye everyone. Be there tomorrow, sharp 10 for the maths class. Okay. Good night, everyone.
भैया बी राइट एंडिंग तुम कर दीजिए